Imagine trying to replace the foundation of a massive skyscraper, like swapping out heavy steel beams for entirely new, untested materials.
Right, and try to do that while thousands of people are still living inside the building.
Exactly. They're just going about their daily lives, expecting the elevators to run and the lights to stay on.
It's a logistical nightmare.
It really is. But I mean, that is the sheer scale and complexity of what India is attempting to do with its entire industrial economy over the next couple of decades.
Yeah.
So, welcome to today's deep dive. If you're prepping for a high-space exam or a policy meeting, or you just really want to understand the future of India's strategic growth, this is your War Room briefing.
Absolutely.
Today we are analyzing a recently promulgated document from the Ministry of Science and Technology. It's called the BioE3 policy. And right off the bat, we need to be clear, this is not just another standard regulatory update.
No, not at all. It's not some minor green energy subsidy either. When you really dig into the source material, you realize you are looking at a master blueprint. I mean, it's a structural overhaul.
Yeah.
The government is basically attempting to orchestrate this massive nationwide pivot away from centuries of, traditional chemical-based manufacturing.
And shifting toward high-performance biomanufacturing.
Exactly. It's a total rewrite of the country's industrial operating system.
So to ground this conversation right away, let's establish what BioE3 actually stands for. Because, if you're mapping this out for an exam or a brief, those three letters are your anchor.
Your mental anchor, yeah.
Right. So the E3 stands for economy, employment, and environment. Those are the three core pillars.
And the ultimate mission here, the national goal, is using this policy to supplement, not just replace, but supplement traditional methods to hit a net zero carbon economy.
While simultaneously driving toward Viksit Bharat.
Yes, the goal of a fully developed India by 2047.
Okay, so we know what it is. But why do we need a dedicated biopolicy right now? Like, what is the structural problem they're actually trying to solve?
Well, the underlying philosophy here starts with acknowledging a pretty fundamental flaw in how global economies have grown. Right now, our industrial architecture operates on a linear model.
Like a one-way street.
Basically, yeah. Think of it like a massive one-way conveyor belt. We extract finite resources like petroleum or minerals straight from the ground. We process them using enormous amounts of energy.
Right.
We manufacture consumer products, and eventually those products reach the end of the belt and just get dumped into a landfill. It's a straight line from extraction to waste.
And the chemical processes used along that entire conveyor belt are, they're notoriously toxic. They produce emissions and byproducts that actively degrade the environment.
Which is exactly why this transition is so critical. The mandate of BioE3 is to pivot from that linear conveyor belt to what they call a circular bioeconomy.
A circular bioeconomy. Okay, I like that term.
Yeah, so if the linear model is a factory built, the circular model is like a forest.
Oh, that's a good analogy.
Right, because in a healthy forest, the concept of waste literally does not exist.
Right, the fallen leaves just decompose.
Exactly. They decompose and become the nutrient-dense fertilizer that fuels the next generation of undergrowth. Everything is reused. So the policy aims to mimic that biological loop, but on a massive industrial scale.
Without actually halting economic growth.
Right. It's about using biological resources to keep materials continually in use, minimizing waste entirely.
It's like we're trying to swap out a car's gas-guzzling engine for a clean, bio-based engine.
So the car is speeding down the highway.
Yeah, speeding down the highway toward 2047. But wait, if the goal is to shift to this organic, circular model, why is the government getting so heavily involved in building physical infrastructure?
What do you mean?
Well, looking at the framework, they are mandating these state-backed biomanufacturing hubs and biofoundries. Shouldn't a transition like this just be left to market forces? Let the big pharmaceutical or ag tech corporations figure it out.
You could, but if you leave a transition of this magnitude entirely to market forces, the innovation usually stays locked inside private corporate silos.
Ah, right. Intellectual property and all that.
Exactly. And furthermore, the economic benefits and those high-paying jobs, they almost exclusively concentrate in major metropolitan tech hubs.
Right. The usual big cities.
Yeah. So the strategic logic built into BioE3 is specifically designed to decentralize this technological revolution.
Mm.
They are deliberately targeting Tier 2 and Tier 3 cities to host these new biomanufacturing hubs.
Okay, let's pause on that and break down what a biofoundry actually is. Because when I hear the word foundry, it makes it sound like a 19th century steel mill with giant smokestacks.
Yeah, it's not a great mental image for biology.
Right, but based on the research, it's actually closer to a highly advanced brewery.
That's a perfect way to look at it.
So instead of using traditional yeast to ferment wheat into beer, you're using genetically programmed microbes. You feed them raw biological material, and they literally brew industrial-grade bioplastics.
Bioplastics, aviation fuel, complex pharmaceutical ingredients, you name it. Yeah, the high-tech brewery analogy really captures the mechanism. And understanding that mechanism explains exactly why these facilities are being placed in Tier 2 and Tier 3 cities.
Because of the fuel source?
Yes, these modified microbes need to eat, and their primary food source is agricultural biomass. So crop residue, organic waste, basically the biological byproduct of farming.
Which solves a massive geographical problem, actually. I mean, you absolutely do not want to transport millions of tons of agricultural waste from rural farmlands all the way across the country into a megacity.
No, the logistics alone would generate massive carbon emissions. It would defeat the entire purpose.
Right.
So by placing these biofoundries closer to the agricultural source, you process the biomass locally. It regionalizes the supply chain.
So you're solving the logistical nightmare, addressing issues like stubble burning, and injecting cutting-edge infrastructure into smaller regional economies all at once.
Exactly. It's multi-layered problem solving.
Okay, so if we are literally brewing alternatives to chemicals in these localized foundries, that fundamentally changes how everyday products are made. And the policy organizes this into 6 core themes.
Right. 6 thematic pillars. If you're taking notes, this is your data memory layer.
Let's rattle them off quickly for the mental map. Number 1 is bio-based chemicals and enzymes.
Right, which is basically phasing out the traditional chemical industry.
Shifting from drilling crude oil for plastics to using engineered bacteria for biodegradable polymers.
Exactly. Once you master programming a microbe to produce a polymer, you can apply that logic anywhere. Which leads to the second pillar, functional foods and smart proteins.
Right, enhancing food security. And then the third is precision biotherapeutics.
Targeted healthcare, yeah.
Fourth is climate-resilient agriculture. Fifth is carbon capture and utilization.
Converting greenhouse gases into resources.
Right. And then there's the sixth one, which really surprised me. Futuristic marine and space research.
Yeah, that one usually catches people off guard.
I mean, yeah. Seeing deep ocean exploration included in a domestic jobs and environment policy threw me off. What does sending microbes to a space station have to do with building a circular economy here on Earth?
It comes down to finding entirely new frontiers in biomanufacturing.
Mm-hmm.
Specifically, the search for extreme biological adaptation.
Okay, explain that.
So think back to those biofoundries we just talked about. To run those massive industrial vats efficiently, we need incredibly resilient biological tools.
Right.
If you want a specific microbe to break down plastic waste inside a commercial reactor that gets incredibly hot or highly acidic, your standard everyday bacteria will just denature and die.
They can't survive the factory floor.
Exactly. So you have to find organisms that already thrive in those nightmare conditions.
Which leads you straight to deep-sea hydrothermal vents.
Or organisms exposed to the microgravity and high radiation of space. These extremophile microbes have spent millions of years evolving unique proteins that don't melt under intense heat.
Oh, wow. So scientists isolate those genetic traits and integrate them into our domestic factories. That is a highly strategic long-term play.
It's about discovering novel biological building blocks before rival nations do.
Let's move from that high-level policy theme down to the ground-level impact. How does this actually affect those 3 E's we talked about? Economy, environment, and employment.
Well, starting with the economy, particularly agriculture, this is where the policy moves from the factory floor to your dinner plate. The big concept here is biofortification.
Right, and it's important to clarify that this isn't just about maximizing crop yield. It's about fundamentally altering a plant's nutritional profile.
Yeah, biofortification is brilliant. In traditional manufacturing, we artificially enrich foods with vitamins at the very end, like spraying iron on a breakfast cereal before it goes in the box.
Right.
But biofortification happens at the genetic level while the plant is still in the dirt. Scientists tweak the crop's DNA so it naturally absorbs higher levels of zinc or iron directly from the soil.
So you're combating population-level micronutrient deficiencies at the root source, literally.
Literally. And if we follow that thread to human healthcare, the policy places a massive emphasis on precision biotherapeutics.
Which is huge. I mean, traditional medicine usually relies on broad-spectrum chemical drugs that flood the entire body, which is why chemotherapy has such severe side effects.
Exactly. Precision biotherapeutics involves highly targeted biological drugs, like personalized mRNA therapies that only attack the disease cells.
Leaving healthy tissue untouched. And by building domestic capacity for this, India changes the paradigm from importing expensive therapies to making them locally.
Exactly. Now, for the environment, the second E, we have to look at bioremediation.
Right. Instead of relying on heavy machinery to dredge a contaminated river or dumping harsh chemicals to neutralize an oil spill.
You deploy customized microorganisms that naturally digest and neutralize the heavy metals and toxins. You're using biology to heal the ecological damage caused by the previous era of industrialization.
That's incredible. But we need to address the third E, employment, because when people hear biotechnology, they picture a PhD in a pristine white lab coat.
Yeah, that's the stereotype.
Right. So if this policy requires advanced genetic engineering and space research, how does it generate broad-based, everyday employment?
Because the scientists in the lab are just the tip of the spear. The true socioeconomic engine here lies in the localized supply chains.
Multiplier effect.
Exactly. When you drop a biomanufacturing hub in a Tier 2 city, you suddenly need extensive logistics networks to transport the agricultural biomass. You need facility technicians, equipment maintenance crews.
Supply chain managers, software operators to monitor the bioreactors.
Yes. Plus, introducing biopesticides and climate-resilient seeds creates a whole new ecosystem of agritech startups that interface directly with rural farmers. It's a massive push for rural employment.
Okay, I have to say, looking at all of this, smart crops, pollution-eating bacteria, rural tech hubs, it sounds almost too perfect, like a beautifully engineered green utopia.
Right, but we need a reality check.
Exactly. I'm playing the skeptic here. Where does this grand vision hit a wall? What are the actual implementation hurdles?
If you're critically evaluating this for an exam or a policy brief, you have to look at the bottlenecks. The most glaring hurdle is sheer capital constraint.
Money.
Yeah. A major component of the policy relies on establishing bio-AI hubs. These are massive supercomputing centers dedicated to running highly complex artificial intelligence models.
Right, to predict 3D protein folding and design genetic sequences.
Exactly. Building and powering that level of infrastructure requires staggering financial investment.
And honestly, even if the government secures the funding, we run straight into the human element, the talent gap.
The talent gap is arguably the most critical vulnerability.
Because we can buy the hardware, but finding professionals with a deep understanding of molecular biology who also know advanced AI, I mean, that's incredibly rare.
If the hardware outpaces the human capital, the entire system stalls. Capacity building training, the next generation of bioengineers, has to happen concurrently.
And then, once you solve the talent issue, you step into the bureaucratic reality, regulatory compliance.
Right. Biotechnology operates on a global stage, governed by intense biosafety regulations.
Which is necessary. I mean, if we're editing the DNA of crops or making plastic-eating microbes, you need strict oversight. You don't want a new bacteria accidentally leaking and consuming a city's plastic water pipes.
Absolute safety is paramount, but it creates a delicate balance. The domestic framework has to be robust, yet agile enough that it doesn't suffocate startups in red tape.
Because if it takes 5 years to get regulatory approval for a biodegradable polymer, the global market will have already moved on.
Exactly. And that brings up the invisible hurdle. Public acceptance.
Oh yeah, public trust.
You can engineer the most climate-resilient, highly nutritious, smart protein on the planet. But if consumers are wary of eating it because they don't understand the genetic science,
Or they're afraid of AI integrating with biology.
right, then the entire market collapses. Public trust is the invisible infrastructure here.
And hovering above all these domestic challenges is relentless global competition. The US, China, the EU, they are pouring billions into synthetic biology. They aren't waiting around.
No, the market conditions are shifting daily.
So if we pull back and look at the entire board, how should we ultimately frame the significance of the BioE3 policy? Because it's clearly way more than just a green energy initiative.
Fundamentally, it is a strategy for national security and strategic autonomy. It ties directly into the broader narrative of Atmanirbhar Bharat, or self-reliance.
Right, insulating the domestic economy from external geopolitical crises.
Think about the severe global supply chain shocks lately. If India can produce its own high-value pharmaceuticals using local microbes and generate biofuels from its own agricultural waste.
It drastically reduces reliance on international imports.
Precisely. You are securing your food supply, healthcare, and manufacturing using entirely domestic biological resources. It's an assertion of economic sovereignty disguised as a science policy.
Wow. Okay, so if we're wrapping this up into a strategic mental framework, a final revision capsule for the listener, let's distill it down.
That's good.
5 must-remember facts. Go.
1. Promulgated by the Ministry of Science and Tech. 2. E3 equals economy, employment, environment. 3. Targets net zero and a developed India by 2047.
4. Focuses on Tier 2 and Tier 3 cities for biomanufacturing hubs using local biomass. And 5. Establishes bio-AI hubs and biofoundries.
Perfect. And if you're looking for a probable policy or exam question, think about this. Critically analyze the role of the BioE3 policy in transitioning India to a circular bioeconomy. What are the key institutional and regulatory bottlenecks?
That's a great one. And the analytical keywords to sprinkle in.
Circular bioeconomy, bioremediation, precision biotherapeutics, biofortification, and strategic autonomy.
So, in a 30-second summary, the BioE3 policy is India's roadmap to replacing chemical-based industries with high-performance regenerative biomanufacturing. It targets everything from carbon capture to targeted cancer drugs, leverages local biomass to create regional jobs, but faces steep challenges in funding, global biosafety compliance, and finding skilled talent.
Nailed it.
It really feels like we are watching the foundational architecture of the next 50 years being drafted in real time. We're transitioning from extracting what we need from the earth to programming biology to grow exactly what we need.
The sheer ambition is undeniable. But as we discussed, the ultimate success hinges entirely on execution.
Right. And earlier we talked about using bio-AI hubs to discover novel extremophile microbes,
Right.
literally programming them to manufacture our future. It represents an almost unimaginable shift in human capability.
It really does.
But looking at the trajectory of this technology leaves me with one lingering thought for you, the listener, to mull over. As we unlock the ability to design bespoke organisms, as we merge the predictive power of artificial intelligence with the building blocks of biology, the question isn't just whether we can build a circular bioeconomy.
Right.
The real question is, as this technology becomes the foundation of our world, who ultimately gets to write the source code for our environment?